بسم الله السلام عليكم ورحمة الله وبركاته. The title of our lesson today is the problem with the naked number. The main problem in physics is the naked number. Imagine I said 2 and I stopped. Everyone will ask, what does it mean? 2 what? 2 meters, like the height of the door, or 2 seconds, or 2 pounds, or 2 kilograms, for example, at the mass of orange or something, 2 gigahertz at the speed of computers, 2 what? So the main problem in physics, you cannot write a number without unit, a value, a numerical value without unit. So a numerical value without unit, meaningless in physics. So unit is must. So the title of our lesson today, units and physical quantities or the physics language. I'm going to share the screen of my iPad with you. Let's start together. Bismillah. As you can see here, I give you an example of 5.0 kilogram. Everything here has a meaning. In physics, 5.0 is not the same like 5, is not the same like 5.00. It depends on the precision, and the significant figure depends on the precision of the tool I used to measure. For example, here in this example, 5.0 means what? Means that this balance can measure till 1/10 or the precision of the tool I used to measure the mass of this object is 1/10 of the kilogram. So 5.0 is accurate to 1/10 of the kilogram. So it's so, you can say it's a precise measurements because it's still 1/10 of the value. So 5.0, I'm sure that it's 5.0 kilogram. And I cannot say 5.0 and say nothing. In physics, in math it's accepted, but in physics, something else. A number without unit is meaningless, and you can consider it as the golden rule in physics. A number without unit is meaningless. So a number with unit is very important. Physical quantities in the syllabus can be classified into main branches. Base physical quantity or fundamental physical quantities and derived physical quantities. Fundamental or base and derived. The fundamental, actually, they are 7 fundamental or 7 base physical quantities: length, mass, time, electric current, temperature, quantity of material, and light intensity. These are the 7 fundamental physical quantities. In our syllabus in IGs, we are going to study only 5: length, mass, time, electric current, and temperature. And of course, we are not going to forget their units. The unit of length is meter, and the unit of mass is kilogram, unit of time is second, unit of electric current, amperes, unit of temperature is Kelvin. And you can see the short is for these units. And we have something else, the derived physical quantities that formed from the combination of base physical quantities. While base physical quantities, they are physical quantities that cannot be expressed by any other physical quantity. Here, like the height of the door is 2 meters. So I said the height of the door is 2. 2 what? 2 meters, 2 centimeters, 2 kilometers, 2 what? So you need to add the unit. So unit even for the length is, you need to make estimation. Of course, a door and the height of the door will be around 2 meters, or of course, it will not be centimeters or kilometers. It is impossible. So for physical sense, you need to put a reasonable unit for measuring the height, for example. The bag in front of us is 1 kilogram. The unit of heartbeat is 1 second. The unit of time, the charger, the phone charger is around 1 amp. And the temperature is the normal temperature or the room temperature is 293 Kelvin. Even if it is not commonly used, and actually we use degree Celsius for measuring the temperature, but still the unit for measuring the temperature in SI unit is Kelvin, not degree Celsius. For the derived physical quantity, we have SI units for force, which is Newton, SI unit for work, which is joules, SI unit for power, which is watts, SI unit for pressure, which is Pascal. But still, we need to derive it. And for example, if I said, let's insert a blank page. Force actually equal mass times the acceleration. What is the unit of mass? Mass unit is kilogram. What is the unit of acceleration? Is meter per second squared. So the unit of force is kilogram meter per second squared. If I'm going to speak about momentum, momentum is the product of mass and velocity. What is the unit of mass? Is kilogram. What is the unit of velocity? Is meter per second. So the unit of momentum is kilogram meter per second. Let's see some other example. Like I said, work equal force times displacement. Force times displacement. But the unit of force is Newton in SI unit, but it's not the base unit, the base SI unit. It is the SI unit only. Kilogram meter per second squared multiplied by meter. So it will be kilogram meter squared per second squared. And if we are going to speak about power, pressure is the normal force acting per unit area. What is the unit of force? Is Newton. What is the unit of area? Is meter squared. What is the unit of pressure? Pascal. P capital A small. The derived units like energy in joules, power in watts, pressure in Pascal, electric charge in coulomb, these are derived physical quantities and can be expressed by other physical quantity like the base quantities, kilogram meter squared per second squared. You can write it per second squared, or in the negative index, as you can see, second to the power of -2. And you can say kilogram meter squared second -2. Okay, let's go to the prefixes. Prefixes are letters written before the unit, giving the unit a value, bigger or smaller. The physicists, they don't like to write too many zeros, and instead of writing too many zeros, they can use prefixes in such thing. Like if we are going to say the base unit is 10 to the power of 0, and if we are going to go down to smaller value, we are going to multiply it by 10 to the power of negative, like centi. We are going to multiply by 10 to the power of -2. It will be centi. And then 10 to the power of -3, milli. 10 to the power of -6, micro. 10 to the power of -9, nano. And of course, they have shorts. And if I said milliseconds, if I wrote M and I left a space and I wrote S, it will be meter second. It is not millisecond. Millisecond written like this, MS without space, still wrong. M capital means mega. So there is a big difference if you wrote a letter in capital or small. So millisecond, actually M small, beside it S small, so it's millisecond. Milli is a prefix, means 10 to the power of -3, or 1/1000, or 1,000th of the seconds. Imagine I have a unit of time, which is second. I divided it into 1,000 parts. I'm talking about one part of these 1,000 parts of the second. So 1,000th of the second is millisecond. And we have micro. Micro means 10 to the power of -6, and they have a certain samples for centi, C, for milli, M small, for micro, mu, a Greek letter, for nano, N small. And instead of writing all these zeros, because of course writing too many zeros means you are going to make a lot of mistakes. If we went here, you will find that we have for bigger values, or we can say it macro scale, and we have micro scale and macro scale. The macro scale for the bigger values like kilo, a prefix K for kilo, and actually we are using in our daily you talk right now, how much you bought your mobile, your car, your whatever you are going to, or your laptop, you are going to say 2Ks, 3K, it means 3,000 or 2,000. Instead of saying 1,000, and it's like a bigger thing or like heavy word, you can say K, and it is coming from the prefix kilo. K is short for 1,000 10 to the power of 3, like kilometers, 1,000 meter, kilogram, 1,000 grams, kilo Newton, kilo hertz, kilo watts, like this. And we have mega, and we have giga. Mega is 10 to the power of 6, 1 million. Instead of writing 1 million and 6 zeros, we are going to write a big letter M beside it, beside the hertz, 1 megahertz. If I said 1 gigahertz, it's 1 billion hertz, 10 to the power of 9. For example, if I said the average distance between the Earth and the Sun is 150 million kilometers. You can remove 3, it will be 150,000 megameter. And you can remove the other 3, it would be 150 giga meter. Of course, don't leave a space between both of them. I think it would be simpler if I said it in this way. Okay? Density trap and speed trap and time trap, sometimes they are going to give you the unit of time in hours or minutes or days, and you need to convert it to seconds because the SI unit for time is in seconds. So 1 hour, how many seconds are there in 1 hour? 1 hour, if I'm going to convert in 2 minutes, imagine I have 1 hour, I'm going to convert in 2 minutes, I'm going to multiply it by 60. So 1 hour contains 60 minutes. How many seconds are there? I'm going to multiply by 60. So I multiply it 1 times 64 minutes and 1 by 64 seconds. So it would be 3,600 seconds. The number of seconds are there in 1 hour. The unit of density is kilogram per cubic meter or gram per cubic centimeters. And we can convert between them easily. 1 gram per centimeter cube, we can convert into 1,000 kilogram per cubic meter. The unit of time, the unit of speed is either kilometer per hour, and it is commonly used, or meter per second. In our problems, actually, we are going to use the SI unit, and we are going to use meters per seconds instead of kilometers per hour. But sometimes you need to make it closer to your mind or to understand it or to solve a problem. So you need to convert from kilometers per hour to meter per second. So to convert from kilometers per hour into meters per second, actually you are going to divide it by 3.6. And if you are going to reverse the process by converting it from meter per second into kilometers per hour, you are going to multiply it by 3.6. That's it for our lesson today. I think we covered all points regarding to the base units, the derived units, and the prefixes, and the conversion between them. Until I meet you, I wish you all the best.